It hasn't. Oh, good. Okay, Donna started our recording. All right, well, let's get going then. Thank you all for joining us today. We're very, very happy to have Rajiv Shah here with us. And I'm going to let him introduce himself in just a moment. But I'll just do the little intro to our Govys. This is a group sponsored by our consortium, the American Statistical Association, and Data Community DC. And hopefully, Donna, you'll let me know if I forgot anybody. It seems like I might have, but anyway. We meet monthly. Usually it's the third Thursday of the month, but it's a little bit different this month because we really wanted Rajiv here to give us a talk on AI. And so I think I'll just not take up any more time and we'll give it to him. Oh, but I guess a little bit of housekeeping. If you have questions for Rajiv, please put them in the Q&A or the chat. He's going to stop periodically throughout his talk and address the questions. And then I think we'll have time for more Q&A at the end. Rajiv, take it away. Thank you so much and looking forward to your talk.
All right, let's get this all kind of fired up here and hopefully you can see, and I want to just see if I can make sure I can see the question answers here.
Yes, I can see your slides. They're not yet in presentation mode, but
okay,
I can see it. I can see your sharing.
All right, and I have the question answer set up as well. So let me find my mouse here. All right, good to go here. Hopefully everybody can see and hear just fine. So welcome everybody. I'm Rajiv Shah. I currently work at Snowflake. I just came over here. Previous to that, I worked at Hugging Face for several years as a machine learning engineer. And then I've been in the AI ML space for many years, worked across various AI startups, worked places like State Farm and Caterpillar. So kind of did data science back in the day. Was a was a very good user of R as well, although I kind of like the tidyverse as well. So today it's a little bit different than R. We're going to talk about generative AI. As we go through this, if you have questions, feel free to put them in the question answer. Like, I like the questions. I like the energy back because sometimes it's hard talking to the camera. I'll pause as I go through this as well. Now, if you like this, feel free to follow me on LinkedIn. I post on this stuff regularly. If you like videos, I also spend a little bit of time my kids got me into this, but I do TikTok videos and I do Instagram Reels now as well. So you can go and find those on those media sites. If you start looking around for data science or analytics TikToks, you'll find me pretty quickly like that. So let's jump into this. Please, yes, give me the energy back as we go. If you have questions or kind of other chat, you can do, I think, other chat in there as well. So to kind of start off with, right, like we've had some crazy things over the last, year, 2 years. We have this company, OpenAI, and I had to revise the slide since the last time I did this at the census, right? Like they've just reported $2 billion of, revenue by year. And then if you were watching the financial news yesterday, and again, like I need to revise the slide, right? NVIDIA is just blowing through the roof. I don't know what the market cap is now with the new kind of the latest stock raises, if it's almost to 2 trillion, but this company that makes GPUs is now one of the top 4 biggest companies, right? It's just an amazing kind of run we've seen in this space that's, all around kind of as generative AI, large language models, as we'll talk about today. Now, when we start talking about this stuff, I also like to point out that it's a very real phenomenon. Like we've had some early research looking into what are the impact of these large language models. If you give people in the real world these tools, the research is saying like it does help in tasks. It'll improve their productivity, let them do more tasks, work faster, higher quality. I'm sure some of you have kind of felt this yourself if you've been using these tools as well. And so because of this, we see lots of action by enterprises. I see everybody's out there kind of testing these things out, trying different types of use cases, as we'll talk about. Early companies are already kind of instant, taking time to implement these. And then you have some other companies that are like, well, maybe we want to build our own. Maybe we want to invest resources in having our own models. And we'll talk about all that as we go through all this. But that's just to give you some of the motivation for what's happening. So for today, what I want to do is I want to talk about what are the aspects of one of these large language models, like a ChatGPT, because I want to give you the technical underpinnings of how these things work, because it allows you to better understand what's going on in the world, what are the implications, how you would actually use this. So I'll spend probably the first 15 minutes or so, 20 minutes on this. And then after that, I'll talk about some of the trends that are going on around large language models. And this just allows me to address a number of like other issues that often come up in these types of scenarios as well. Give me 1 second here. I want to see if I can move that chat over. See that at some point as well. All right. Okay, excellent. Yes, let's keep it fun. And yes, please share that energy back. So to start with, if you've been in the data science world, you're used to classification models, regression models, where you're trying to make some type of prediction. The difference with language models is you're trying to predict the next word is often how the problem is set up. And if you think about it, like if you just take a look at this sentence and you're like, if you had to build a linear regression or an XGBoost or whatever model to do this type of task, like it's not a simple task, is it? Like there's a lot of different ways language could go. This would be a kind of a very hard prediction task to do. But at the heart of when we talk about large language models, that's what they're really trying to do, is do that next word prediction at kind of the root of it. Now, as they're doing this type of prediction, so as they're doing this type of prediction, it's a statistical prediction, just like your traditional machine learning, the what you do. And so it's not like they know the truth when they're doing this. They're just trying to make the best type of prediction based on their past data that they have for what that next word is. And so because of this, I like to just always call them dream machines. They're just trying to make predictions based off what they've already learned. It doesn't necessarily have any correspondence to the truth in terms of the question that you're doing. And it's important to kind of keep this in mind, as this will be a reoccurring pattern as this kind of comes up when we're trying to understand why these models are making certain decisions along the way. Now, if we look at kind of the history of these models, an early model, right? This is at this point like 5 years old. It was GPT-2. And this would do exactly that next word prediction, where if I gave it a sentence, it would keep trying to complete it. And, this was very nice if I wanted to use it to tell a story, for example, right? Like you can see the example there. For me as a practicing data scientist at the time, I was like, time series is much more interesting, much more impactful. Like this is cute, but like how many companies need somebody to kind of write fictional stories for them? But even this model here was not easy for OpenAI to build. It was trained on something on the order of 10 billion tokens. And we'll talk a little bit more about all of that data. Now, you're probably like, hey, Raj, this is ancient history. Like, tell me about some of the newer stuff. So let's go and talk about kind of what we see with something like GPT-4 and how it's been trained. And OpenAI, they've written like a 150-page technical guideline that came out with GPT-4. And if we start peering and kind of looking into it, we can start seeing the details, or actually, they don't actually give us the details on the architecture, the hardware, the training data set, the training methods, any of those like details that you'd want to know as a technical person. None of that, right? Like we don't have that. So we don't exactly know what's in GPT-4. It's really a black box for all of us. Other folks have stepped into this, most notably Meta has produced an open model where it's not true open source, but they've explained exactly how they built, they've shared out the model with us. So their earliest version of this, the Llama 1 model, they shared exactly what was the data that went into kind of building this model. Now, the first version of this model was built with 1 trillion tokens. Now, newer models are nowadays built with like 6 million or even more. But to give you a sense, like, what is 1 trillion tokens? Like, how does that compare to the human experience? If you went out and you got a book and you just sat under your favorite tree, you started reading, and you started reading, you read, for continuously for an hour, kept going, right? You read all afternoon, evening, day, year. If you read for 10 years continuously, that would be 1 billion words, right? So you can see quickly the math here. That's a billion, right? These models are exposed to 1 trillion. So you can understand like the amount of knowledge that's in these models. Our brains can't truly comprehend how much they've read along the ways like that. It's really kind of vast, the amount of information that they're given. Now, this was an open model using kind of public data sets. Some companies look around and they're like, hey, we've got a stack of data. Why can't we just train our little model that completes things based on our data? So it does it for the tasks that we care about. And so this is where Bloomberg, and I think this is about a year ago at this point, they have a huge stack of their own proprietary financial data. They're like, well, let's train a model to do that. Now, to do this takes kind of resources, technical resources to do this. And they shared, Bloomberg was great because they shared exactly what they had to do to train this. And so they had to use 512 A100s. And if you're not familiar with kind of GPUs, A100s are a type of GPU. You can think of them, they sell for like something on the order of like $10,000 to $15,000. You can rent them for like $1 or $2 an hour. So you can see there's a substantial amount of money that Bloomberg spent on training this model. Now you might be thinking like, so does this take a large group of people? Like, do I need 100, 200 people? What do I need to kind of to be able to train something like this? Well, for Bloomberg, and actually you see it with lots of these other teams coming up, startups like Mistral, you don't need a huge set of people to build this. A relatively small team that's dedicated, that understands these technologies, are able to build these models pretty quickly like that. Now, Bloomberg built this model and they were pretty happy with it. When they looked at how it did on various financial tasks that they cared about, the model did better than the existing open source models. So, it was a better solution then than there. Now, as we talk about it, this doesn't hold forever, but at the time when they kind of built that model, it was pretty useful for them. Now, one of the things we have is Meta's one of the contributors that's built open models, but there's a lot of other companies building out these foundation models, these models that complete the next sentence, and then just sharing them out with everybody. And if you've been in the space for a while, we had Llama 2 was a big model a couple of years, and then we had kind of the Falcon model, we've had the Mistral model, the new Minstrel kind of ensemble model, right? Google released a model yesterday. There's so many of these kind of models that are coming out that are changing on a regular basis as well. And so that's the first step, is you need this kind of foundation model been trained on lots and lots of data. But those models just do that next word prediction. So this is where we're going to change it up, where we're going to go to these instruction fine-tuned models. And what we're going to do is we're going to take this model that we've created and we're going to train it for a task. And here, this is like traditional data science. We're going to show up with a bunch of labeled data. Like, here's the examples that we care about, movie reviews. Here's how the model should react to them. The sentiment is positive, negative, and we'll train the model. And you can fine tune these language models. So what you're doing in fine tuning is altering some of the weights of the model. And you could teach it to become a movie review classifier. It works. Researchers then kept playing around with these models and they said, you know what? Yeah, we can train it for sentiment, but can we train it for more? Well, they figured out that they could use that same language model, not only for the one task sentiment, but I can also use it to identify topics. And they kept going. And they said, well, you know what? Hey, can I also use it for translation? And this was the crazy thing. This one model could support multiple tasks. But here's the big thing. Here's the mind-blowing thing. What they then figured out was not only could it support multiple tasks, it could take tasks that it hadn't seen before and complete them. Didn't always do them right, but it was able to handle these new tasks. And this is why when you use something like ChatGPT, it's such a great experience because you can give it any type of task. You can ask it to make a rap song. You can ask it to make a poem about anything, and it's able to do that. And this is where kind of large language models have become so popular because they're so flexible that these models, they'll try to do whatever task that we get to them. Might not always be successful, but they'll give it the old shot at this. And so this has been the amazing thing where we've opened up all of these new use cases. Now, the way we talk to these models is there's often you hear the word prompting that's called, and a simple prompt would be, hey, translate I love pizza to Spanish. And in this case, we're just giving it a direct task that we want. And this is what's called zero-shot learning, where we're not giving it any examples. But there's more sophisticated ways to do this prompting. And there's an entire school of thought on this prompting. But here's a simple example of one where I don't tell the model exactly what I want, but I also you could, but I also give it a few examples. And this is where the few shot comes into play, where I give it examples of, hey, here's movie reviews, here's the sentiment. And then based on those inputs, that instruction, the model figures out, oh, you're just looking for sentiments. I can give you the sentiment of this review that you have marked. And so this allows the model to do kind of tasks that would have taken a while to do. Because if you remember back to when you first learned NLP, you probably created a movie classifier and you spent time making sure all that data was labeled, like thousands of rows, training a model to do all that. But nowadays, like the intern, all they have to do is ask ChatGPT, like, hey, here's the data. Hey, will you just give us, the sentiment of these movie reviews? And that's it. They don't have to train a model. They can use the existing large language models with prompting to be able to solve that task. Now, to do this, you're doing that tuning of the models, and there's lots of different data sets out there, these instruction tuning data sets that you can get out there. I think one of the things with the recent release of the Google model, I think they share both a base model that wasn't instruction tuned and a version that was instruction tuned. And it's not hard to do this last step of teaching this instructions. It's usually on the order of thousands of examples. So much less than like the billions, trillions of tokens that we were talking about earlier. So now let's go to the last step of these models, kind of the alignment. And let me bring it back to kind of how we think about things, humans. So when we post a question, for example, on Stack Overflow, hey, I'm looking for advice. I'm trying to understand this. People will post different types of answers. Now, one of the things is anytime you ask people, right, what the answer is you'll get answers of varying quality. Some of the answers might be really good, and you can even skim this and tell right away that it's a really good answer, and you can see it does well on Stack Overflow versus some answers, not so good. But here's the thing. If we look at all the Reddit data, all the Stack Overflow data, all the data that's out there in the internet, there's good answers and bad answers. Right? If we look at that distribution of quality of answers like that in terms of how helpful they are, it's all over the place. But, if you're using a model, if you're using ChatGPT, do you want it to give you D answers? No. You really want the model to give A answers. How can I get the model to just give me the good answers, but not the bad answers? And if you think about this, this is not kind of a simple problem. I mean, if you really kind of stare at what it is that what are the qualities of a good answer versus the bad answer, right? Like put on your data science cap, and if you had to kind of engineer features, if you had to tell a model, like, hey, this is what makes a good quality answer versus a bad quality answer, like this is not the easiest thing to do. And remember, the ability to tell a good answer or bad quality isn't just limited to this domain. Somebody's going to ask a medical question, a financial question, like all these types of questions. You need to be able to tell the difference between them. And like how helpful a question is if you think about it, it's not a very definitive boundary. It's a very blurry boundary. And this is the element of preferences. And this is the last step of these large language models is how do we help when we have these very fuzzy, buzzy borders for kind of training the model to do things? And this is where I like to use the kind of analogy of dating for kind of how we've been able to kind of figure it out. So about 10 years ago, I know it's hard to believe, about 10 years ago, I was out there on the market and I did the online dating. And if anybody remembers kind of how online dating worked about 10 years ago, you'd often fill out all these surveys where the idea was if we had lots of information about you, we could then connect it with other people that shared lots of information about them and figure out who would be a good partner for you that way, right? With kind of by having all of that information. And so that was kind of the way it was done in the past. But if you look at how people are dating now, if you kind of look at the modern approach, it's very different. Just swipe, right? Thumbs up, thumbs down. That's how we collect kind of who's likely to be a good mate or not. Well, the researchers have taken the same idea here to help us with this preference problem with large language models where they go and they collect human feedback. They show humans some answer, and then they say, hey, just give us a ranking. Give us a thumbs up, thumbs down. Tell us what you think about that. And so we're able to collect the human preferences that way. And then the next task is how do we convert those human preferences to to tweak the model, to give us those A inputs, to give us those A outputs and not the Ds. The OpenAI was an early one here to kind of publish its approach here that used reinforcement learning with human feedback. It's a big fancy word, an approach that they used, but they were able to show that, using these techniques, and I'll talk about them in a second, actually made the model much more amenable. People like it a lot better. And, this is one of the things that it's good to understand about tools like ChatGPT is they have explicitly been trained to please us. We've given them lots of examples. So when it's nice to us, it's not that it likes us in any way. It knows that's the way it's been kind of configured, and that's the way it kind of has the lowest loss like that. Now, if we look at the technologies for how we've done that, the earliest work was by folks like OpenAI, and I think the latest Google model also used this kind of reinforcement learning with human feedback, where it used lots of techniques from RL, used humans, complicated, hard to get right for other folks to do. There's been other approaches. Anthropic, for example, has used something there called the constitutional AI, where instead of relying heavily on humans for feedback, they actually rely on an AI model to get the feedback as well. And then recently, in the last few months, and I think this is this has been a big piece of research that's been very important. At NeurIPS, it won kind of one of the awards there for best paper, is this direct preference optimization, which provides a much easier way of using that preference data and combining that and aligning the model to do that. And so if you go out and check, my folks at Hugging Face have kind of printed out or written up an alignment handbook and kind of given you examples of doing this. And this has really allowed just anybody to start doing the alignment of the models, and really kind of we're democratizing that alignment piece, which for nowadays is often used for these fuzzy problems of alignment of helpfulness and harmfulness of models. Right? Like Google's been in the news all the last couple of days because of the alignment around their image model and the biases there. But I think this idea of alignment for helpfulness and harmfulness, I think there's a lot of other fuzzy problems that people are going to be able to use these approaches to kind of help solve as well. So I'm going to pause here. I'm going to take a look at the questions and let me know if you see anything. But this is just a recap of like some of the big pieces, technical pieces that go into building something like ChatGPT. And then we'll break it down and kind of go into some other interesting parts of that, like that. So yeah, I see somebody's recognizing, yes, the pleasing element backfires. Okay. So let's go, keep going. Now, sometimes I talk about the use cases of these models. Often, like if I talk to enterprises, they're like, hey, how are we going to be able to use this? I can talk about that, but I think for most of you would rather know some of the interesting technical issues and where we're going with this. But these are some of the most well-known kind of use cases around this is chatbots, code assistants, right? Like GitHub Copilot, it's kind of made life so much easier as a coder. Agents are a little bit more of forward-looking. Everybody's trying to build them. It's very hard to do that. They're not very useful at this point now, but they have a great ability to kind of change things. So what I want to talk about now is like 4 different trends that I see. Talk about when to use a large language model, when not to, kind of alternatives. What's happening with open source large language models, which of course for government use is very important. Some best practices, like how is this changing the practices of data science? What are some new things that we start seeing? And then the overall kind of market and resources around generative AI. If I'm missing something, this is why we're having this conversation here. Feel free to put it in the questions. I'm happy to kind of cover other pieces as well. So large language models can do a lot of things. But if we take a look at something like sentiment and we see how the model does, we had models like BERT before that we would use for sentiment. So smaller models that understood language. But when we put them aside something like ChatGPT does much better at this, and this is looking at kind of restaurant sentiment. And it's not a surprise here. Right? Like ChatGPT has been trained on much more data. It has a much larger, richer understanding of language. So it's, you would expect that when we're talking about something like sentiment, ChatGPT is going to do better than that. So I think there's no surprises there. And when we get to financial sentiment, you'll see a similar pattern where, wait a minute, why is the FinBERT, the really small BERT model here, doing better than GPT-4? I mean, the BERT model is like 100 million parameters. Like GPT-4 is like a terabyte, right? Like it wins the bar exam and does medical tests and stuff. Like, why is it losing? Well, if you actually look into kind of how these models do, actually, like FinBERT beats GPT-4 in financial sentiment, but if you go over to biology and you're doing some entity recognition, the BioBERT model does better than GPT-4. And if you go over and you want to have a SQL to text model, the SQL coder that's fine-tuned on the data does better than GPT-4. If we look over at chess and chess planning, Stockfish, a chess application, beats GPT-4 in chess. DeepL does better translation than that. And in fact, in many cases, the specialist models will do better than a large language model like GPT-4. And so, yeah. And so this is an important thing to consider, and I'll reinforce this a little bit more. But these large language models aren't going to solve every problem in the best way. And we'll keep talking about different alternatives. So if we talked about that Bloomberg model early on, that they spent all that time training that model just around their financial data, well, it turns out if you just use an open source model and you do that fine-tuning step that we talked about, where we just give it the examples for the task that we care about, you can actually train a better quality model that way. And if you're wondering, like, well, why is this? Well, this llama model was just a higher quality base model. It understood language much better. And so then that last little bit of fine tuning step was a lot easier to do versus a pre-trained model that, yes, it was trained on the proprietary data, but wasn't as good overall. I'm not explaining that very well. It's just basically the llama model came around. It was the newer, later, faster, better model. But this slide here is why so many companies nowadays, first you start with fine-tuning a model. If only that fine-tuning approach doesn't give you really good performance, then you start thinking about pre-training, simply because the pre-training takes an enormous amount of resources. And in my experience, for 99% of the problems, fine-tuning an existing LLM is a much better set of resources to go. So when we start talking about large language models, there's always alternatives to large language models. It could be taking a smaller version of a large language model and fine-tuning it. It could be using one of the older style language models, the traditional BERT models. Might be using something that is not even a large language model. But this is where you should always, right? Data science is all about kind of having your bag of tools and pick out the best tool for the job. And as easy as these models are to kind of quickly prompt, they're not always the best for every type of circumstance. And this is where, I want people to recognize that for many problems, having a specialist, a smaller model is actually going to be a better fit for what you're doing than trying to fit a large language model into what you're doing like that. All right. Everyone with me? Okay, I haven't seen any questions come across here. I'm hoping you guys are all going along like that. So another question I often get is, let's talk about, where we are with the open source, what's going on with it. So this is with images. I should do one with video. Nowadays we've seen the video, but I remember, back a year and a half ago when that DALL-E Mini was big. If you remember, everybody was sending around the memes. The images, though, like the quality wasn't that great. It was a long time relatively to kind of build those out. And we've seen this world of text to image and the open source models in this space. We've seen them just steadily improve. They've been able to get faster and faster along the way. And I think we've seen this in a number of domains around all of this. So I wanted to show a little bit something different than text, but we've also seen this with the large language models as well, where we've, historically, we started off with some of those large language models with GPT-2. We've had lots of organization, Google with their early kind of FLAN T5 models. But over time, we've seen many companies being able to release large language models, everybody building on top of themselves like that. And so nowadays, there is a flood of kind of large language models that's available. And as we'll talk about, like, it doesn't seem to be kind of slowing down in any way. About 2 years ago, if you wanted to run something like Bloom, which was one of the biggest open source models, kind of an international consortium of folks kind of pulled together to build it, that model was, to give you a sense, 176 billion parameters. So very large model. Then to run it took an enormous amount of resources to do that. If you wanted to run the full model at its biggest, to do that, like literally like cluster of like NVIDIA GPUs. And the thing is, the model, like if we look at the knowledge score, that MMLU, it really wasn't that great. But right, kind of a year later, we had Meta releasing by then the Llama 2 model. And all of a sudden you can see a big jump in the knowledge score for it. Now we have a model that's much smaller. It doesn't require multiple GPU. It doesn't require tons of GPUs. You can use a lot less GPU resources. You can even do things like take the model, do optimizations like quantization, other things that you can actually bring the model down to just such a small size that you have people running these models on computers, even some folks trying to run these things on phones like that. And since then, we have lots of other companies that have been building models, putting them out in the open source. We see the steady improvement as well with kind of the knowledge piece like that. So we've seen a kind of a nice trend over the last couple of years with these open source LLMs. Um, all right, I'm taking a look at the questions. I'll get to those questions. Um, now, when we get to these large language models, there's been so many of these. Over at Hugging Face, they have a leaderboard that allows anybody to kind of submit their models. Now, some of these models are those pre-trained, some of these are that instruction fine-tuned or the aligned like that. But when I did the slide a few months ago, it was 1,600. So my guess is there's probably over 2,000 different open source models that have been built that are put on the leaderboard. So it's just amazing. I never would have thought, a few years ago that we would have so many like this. You can go out there, many different ones, right? The Llama models, the Falcons, all of these things that are out there. So, right, the Hugging Face Hub is full of them. And so this is one graph I like to share kind of when we to talk about kind of where we are with open source versus closed source and the capabilities. Now, if we look across many other areas, especially in kind of analytics, as we often see, right, that small closed team that works together then can build something that's better than anything else out there. But what happens is when there are problems that are crowdsourced that lots of people care about, that lots of people have the resources to help and contribute to, you get the growth of open source. And over time, the open source solutions typically are kind of the better solutions like that. So if we look at the trends here, and compute is one of the underlying trends that makes these models smart, we see that, yes, models like GPT-4, the Google's Gemini, yes, they're ahead in terms of overall compute, but the open source models are getting a good amount of compute and kind of keeping pace over time as well. So just lagging a little bit like that. And this is where I always, remind people, there's a horse race going out there about, who's got the latest, greatest kind of model. But at the end of the day, like, you should just be focused on what you need to solve your particular problem. And you might not need the latest, greatest model to do that type of thing. So take the time to evaluate these things on your own tasks as well. Now, one thing I will point out, and this is often why we have commercial models out there, is they fit needs. And one of the big pieces is if we look, and this was a few months ago, so it might have changed, but people like the models, for example, by OpenAI. If you look at the NPS scores, if you look at the satisfaction of that, people do enjoy the experience of that. So I think that's an important kind of counterpoint here to keep in mind as well. But for the government folks, they understand, but for everybody else, right, there's lots of reasons why governments, enterprises might want to pick an open source model over going over, for example, some proprietary API as well. All right. I have a bunch of questions that have come in. I like the questions. So let me see if I ask. I'm going to try to go through these questions a little bit here as well. So one of the questions is, if I ask any of these models an arbitrary logical question, would it answer correctly? And so what that question is getting at is do models understand logic? And this is where it gets very tricky. And I don't think I have this in my slides, but there's often a lot of debate about, can models plan? How organized are they? Can they think 3 or 4 steps ahead? And the research right now shows that models aren't very good at doing those types of planning tasks. Really, what these large language models are doing is they're good at retrieving knowledge, right? Like all that knowledge that's out there that they've learned, they can pull back and give back to you. So when you ask about, can it answer an arbitrary logical question? Well, if like 20 people have answered that question before on Reddit, it can repeat back the answer to you. And so it might very much appear like it understands the logic, but the reality is like it doesn't necessarily know logic. The best way people have found to get these models to get a sense to see if they understand logic is the models that understand code. Because to get your code to run, it has to be in a logical order like that. So the models kind of learn like, hey, what order to put things into like that. And so often you'll see the use of kind of code-based models because people feel like that gives the models a little bit better ability to think in a logical way. All right, that was a long answer. I'm hopefully that gets that. So I can't hit the button to like dismiss the question, so they'll be up here for a minute. Is there any good place that indexes the specialist models? I think, often the specialist models, they're by domain. So this is where having data scientists in those domains is very helpful because they know where the models are. You have places like the Hugging Face Hub that have lots of models, but not every you know specialty group uses that, right? You might have other places you store models or share models like that. So I think this is where like having the domain knowledge of data science is the best place to kind of look for when you're going through that. And this is why we're not going away as data scientists like that. I will talk about hallucinations at the end. I have a little bit about kind of risks like that. And then there's a question by Dimitri about the underlying process. Like, what relationships can deep learning maintain and how does it represent them? And I didn't go into that here. Andrew Karpathy, who's of course well known in this field here, has a great example, and I used it as well, where you train a language model from scratch. And I think it's very instructive to do this because when you train a large language model, it's really doing that task of prediction of that next word. And you see when you don't give it a lot of data, like it comes out really jarbled. It doesn't make sense. But like if you train it over time, the models get better and better with that. And I think that helps you give you an intuitive understanding of like how these deep learning models, they're just raw weights. But if you train them, if you give them enough examples, they start to learn those patterns and recognize those patterns so they can do a better job of doing the prediction. There's also a neat game. I don't know if anybody's seen it before. Maybe they can share it in the chat, where they ask humans to do that next word prediction. Like they give you a sample sentence that and they give it to ChatGPT, and you have to try to guess and predict like what's the next word in the sentence. I mean, it was really hard for me to be able to kind of do that prediction like that. Like these models are really good in doing some of that work like that. All right. Okay. All right. I'll answer some more of the questions in a bit. Okay. So let's talk about some of the things that are really changing in data science that I think it's important to be aware of. The first is how we can use large language models to generate data. So this area of synthetic data has really grown with large language models. And part of the reason is these large language models, they can write at the, at the at least whatever, 8th grade level, maybe 12th grade level, like they can write in a way that that mimics lots of kind of humans. And because of that, we're actually able to synthetically generate data for lots of tasks, whether it's pre-training instruction, preference tuning. You see this quite widely used nowadays as well. Some colleagues of mine recently kind of did an example where they used the examples, the prompts that they gave ChatGPT, used it to prompt and then train that smaller model. Remember I talked about training smaller model? So use the LLMs to generate lots of data, but then LLMs cost a lot more to run, right? There's a lot more compute there. So let's in fact use that extra data, train a smaller model. You can run this kind of a Roberta model for much cheaper than running GPT-3 to kind of process, and in this case, even get better performance as well. Now, this usage of these large language models for generating the data, there's different approaches. There's kind of distillation, where we go from a large language model and try to bring it down to a smaller model for the synthetic data. There's some where you create the synthetic data and you just try to send it back over and over again and improve. This is basically a whole new school of thought in the last year that we're seeing. Just in the last week, somebody released 30 million textbooks that were all synthetically generated. So this is a huge wave that we're going to see that's going to be used for training this. For people doing like the question answer, the RAG use cases, which are very popular, often you'll use synthetic evaluation data sets as well. If you go around and you look at kind of the cookbooks by the different companies, whether it's Anthropic, Llama Index, Databricks, they all have recipes for doing this. So this is all kind of a widely kind of technique that's come around. The second is fine-tuning the models. So we've talked a lot about kind of how we might want to fine-tune the models to increase the model performance. You can also use fine-tuning to kind of make the model smaller by using a smaller model instead of the bigger model with that's fine-tuned. And this is a very effective way to do that. Now, these models can be very large, billions of parameters like that. So one of the things we've seen is the emergence of very efficient fine-tuning methods. So instead of all those 70 billion parameters that I have that I'm going to change with each new example that I get, can I only maybe do a subset, maybe 1% of those, or maybe add another layer that has weights that I want to add in to it? And so we see lots of schools of thoughts. There's a library called PEFT, parameter efficient fine tuning, that's widely used for that. But this is something that you see widely with these, is finding better, more sophisticated ways of doing that. And then the third thing is evaluation with these models has really changed. And I have a whole like hour and a half, 2 hour kind of deep dive that I do on all these different techniques, because in the past, our models, right, classification, it was either A or B or a number, fairly straightforward to evaluate. But now these models can output anything. They can output an image. They can output lots of text if I ask it to generate an email. Lots of different ways for evaluating. Everybody's still trying to figure this out. One of the other notable ways that we see is using LLMs as evaluators. So instead of humans that, right, they're costly, they also have their sets of bias, we can instead ask an LLM, hey, can you rate this particular output? Now, whenever I bring this up, like, especially if you don't kind of live in this world of large language models, people are like, whoa, this is crazy stuff. Like, you can't have models evaluate models. Like, I mean, that's not good. That's no way that's going to work like that. But let me walk you through a simple example just to give you a sense of how this would work. So imagine you want to make sure the large language model you're using is creating emails, marketing emails that are going to get sent out. But you want these marketing emails to be professional. So what we can do, and you can see here, I've got all the information right here, is I can use a model, like in this case, GPT-4, down at the bottom. And then I give it a definition of what do I want it to look for. So it's going to take an email. This is going to review it. And I describe exactly to the large language model, exactly to GPT-4. What do I mean by professionalism? I explain to the model like what I want. And then I say, you read that email, and then here's exactly how to score it. And I give it a grading rubric to use. And if I do this, I can give this email to the model, and I can get an output back from the model where I've given it the email. I can get the score back on that grading scale. A bonus is I can even ask the model to explain why it did it. And that way I have like a textual description and explanation as well. And we see this widely being used nowadays in the space of large language models, is having these other models as a judge like that. And you're like, oh, come on, this isn't going to work. Well, if you compare how these models are judging compared to humans, you'll see there's a strong correlation between the two. And if we look at kind of specific examples, you'll see that in this visualization here, you'll see almost everything was within the same score, or maybe just a slight difference of 1 off. This is like on a 5-point scale like that. Like, the models are pretty much, doing kind of what humans would do on the grading. Now, the one area where they differ a little bit is when the model is grading itself. And so that's that middle column where you see the really high bar compared to that, is the models tend to, and I guess not surprised, right? They're not, they can have their flaws too. They tend to like their own output better. And so the models can be biased that way. And this is one thing, is in the field, you often use a different large language model as an evaluator, because you know that they kind of like their own material. They like themselves. They're a little narcissistic like that. Okay, I'll take a pause. I see there's a bunch of questions like that coming in. So give me a second here. I'm going to try to move my mouse, which is very complicated with my monitor set up here and look at these. All right. Data business is all about tabular data. What's the using generative models with tabular data? And then, yes, I will make the slides available. I don't know how the organizers want to do that, but I have no problem. I'll share a PDF out for the slides as well. So let's see. I have the tabular data question out there and then dashboard creation. Okay, I can't tell if there's anything in the chat. I like you guys chatting, but let me know. Move it to a question if there's anything I need to answer. So most of the data business you care about is tabular data. So let's talk a little bit about this and kind of why we have tabular data and kind of what that means like that. Let me make sure. All right. Now, tabular data is everywhere in governments, enterprises. I think even with the rise of generative AI, 80% of use cases, at least, are still tabular data. And tabular data has a huge advantage when it comes to analytics in terms of it's often things that we care about. Right? Like we have a column for sales because we care about sales. We have a column for customer zip code because we care about where they live. We've already taken the time to put our ingenuity in to structure that data into features that are very valuable. And so this is where tabular data for lots of problems is going to have its advantage. Where the generative AI fits in is when we don't have that. When we're dealing with unstructured data, when we're dealing with conversations between people, right? The emails they write, the conversations they have kind of right sitting with Siri, right? The videos make. All of that stuff is really where it's ripe for generative AI. And I also think one of the biggest areas we've already seen it is it's a nicer interface for humans to work with machines. And you see this in things like text to SQL, whether that works or not. But the idea that I can give a vague instruction and ChatGPT gets and understands what I mean and it kind of solves it. I should put that up. There was a great video on TikTok of like this young woman like giving a rambling question that probably took 45 seconds of talking. And the large language models, they're incredibly patient. They will sit there, they will listen, and then they finally kind of answered her question. And this is the same reason that if you look at the results for do people like engaging with human doctors or AI doctors, they like AI doctors. They're pleasant, they're nice, they're patient. So, there's lots of those different kinds of use cases and areas that we have, but it's in a different realm than the tabular world like that. Now, if you're working in tabular data, you'll probably start using a large language model, for example, to help identify new features, bring in new information. So a simple thing is maybe you have a product and you need to generate features, categories of that. Well, I can give an image, I can give a description of that to a large language models. It can come up and generate those features that I then put into my tabular data set. Maybe you have a bunch of messy data that's coming in. And in the past, you'd create a bunch of regexes to clean it up. But now I could just ask the large language model, hey, can you just extract the company names and the customer's address from this? And it will do that. And then it feeds into your tabular data. So that's where I kind of see that relationship. It's not necessarily like one is going to supplant the other. It's generative AI is going to do a lot of other things, and there'll be, a little bit of the Venn diagram overlap like that. All right. So if I didn't totally answer that, let me know like that. Okay. This is the last big section I have, and then we'll just totally open it up to questions. I like to talk about what's going on with compute. One of the reasons why, and if you talk to researchers in the area, they'll say the biggest reason that we've got here is not ingenuity of the humans, but it's the cold, hard compute that NVIDIA has been able to create. The 1000x compute that they've been able to create is what has fostered the ability of these models to do what they do. And the way this is, the way we figure this out is we take a look at those scores. Remember, I talked about that MMOU, that knowledge score. When folks plot it out, they often see that there's a strong relationship between the amount of compute that goes into these models and how well they do on this knowledge score. And if we look back over the last several years, it follows a very, well, maybe not linear, but it follows a relationship there. And this is why people are investing so much. This is why Meta's buying GPUs, why OpenAI is building GPUs, is based on what we know in the past. There's a strong relationship between compute and the ability of these models. And we have every reason to believe, and I have no idea where these models are going to go, but we have every reason to believe that it's entirely predictable and that they'll continue on this path if we give them more compute like that. The latest OpenAI Sora release, the model that was text to video, some of you have seen, they have an excellent example there of the difference in the model between the base compute versus if they give it 4 times the compute versus if they give it 32 times compute. And you can see again, like how the quality improves much better. So, throwing this compute at it does make a difference. And this has been a steady piece over the last couple of years, is just enormous amounts of compute. For those who have the environmental concerns, I don't know what to say. Like, it's just crazy how much we're doing, and we know kind of how dirty all this chip manufacturing is as well. But this is just kind of the way the industry is going right now, and it's chasing all this compute like that. To give you a sense of like the compute for this, I took a distilled BERT, which was 3 or 4 years ago would have been state of the art, which was kind of a great model you could run on a CPU, widely used. Probably more models running that than Llama 2 out there like that. But if we take something like a small model like that, and you compare what is the compute requirements for that versus a Llama 2 model all the way to a GPT-4, and I couldn't get my head around like the numbers here, gigaflops, teraflops. So I kind of changed it up to make it a little bit easier to understand. So something like Distill BERT, you could run that on your iPhone 8. Like, you don't even need a new iPhone. Like the old iPhone that I give my kid, he could run kind of Distill BERT on that. Now, something like Llama 2, if you take the smallest one and you quantize it, like you got to muscle it a little bit, but folks have done it. They've got it running on their iPhones like that. But on the other hand, if you take something like GPT-4, of course, it's a black box. This is all speculation. We don't know exactly what it is, but it literally takes like a cluster. It takes multiple of these like, $20,000 cards to be able to run it. And so there you can see just the enormous amount of like compute and energy, which of course translates into environmental costs, translates into money as well, kind of when you're thinking about it. So this is kind of the trade-offs around that. So that's one piece, is what's happening on the hardware side. Another trend we see is on the data side. A couple of years ago, like data scientists, like 101 was like, hey, you go out and scrape a bunch of data to do your capstone, your intern project like that, and go out and scrape tweets to do that, use Reddit. Like, that world has changed dramatically like that. Like, the internet is no longer kind of a free, easy scraping place to go. These companies are realizing, like, look what's happened to Stack Overflow, that their data is valuable and that they want to maintain control over it. In the last week, I think Reddit saw something like it sold its data to some mysterious person for like $60 million like that. Now, there's other organizations fighting back that are trying to collect data, trying to put it out there as well. But this is a tension. There's also through all of this, all the ongoing copyright issues too. The lawsuit against GitHub Copilot, against Stable Diffusion on the image side like that goes on as well. So there's a lot of pieces going along with that. Meanwhile, we have a lot of eyes looking at this. These models have a lot of researchers are working, and there's been steadily improvements in the architecture of these, whether we talk about kind of how we do the position embeddings. I think flash attention is a great example of how the ingenuity of both understanding algorithms, but also understanding like how GPUs work, and that, hey, there's a faster cache here and there's a slower cache here. And if we effectively kind of use the fast thing as much as we can gain performance improvements. Thinking about things like multi-query, because we're running these across multiple ones, we can find more efficient ways. So that's been a ton of work that's been done, and the models have also gotten faster that way. Multimodal, I think we're all probably aware of this. Maybe this was a great slide 6-8 months ago, but right, multimodal is coming out, and we're going to see more and more of these models like that. Interesting, if you look at these two, the one on the left side was entirely made by a large language model. The one in the middle that actually won like the top overall price was built by a combination of humans working with the model. And so this is where, we're not going to be totally replaced like that, but we're going to see multimodal. We have text, we have the folks in biology have kind of a bunch of multimodal models there. They're working with different types of modality, images, DNA, all this kind of stuff is coming in as well. Now, let's spend a few minutes talking about kind of the risks of the models. So one of my favorite stories was there's a lawyer in New York. They're trying to get their brief out real quickly. They decided to use ChatGPT. Hey, let me use this help, right? It's an important point of law. ChatGPT knows, they know the relevant cases. Cut and paste that, put that into my brief that I give in front of the judge. The judge, they go to look at it. I'm like, wait a minute, like they try to like double check the road. Like they want to look up the citations. The citations aren't there. They don't exist. Right? ChatGPT hallucinated, literally made up the citations for this. And so this has been a big to-do in the legal world at making sure like lawyers don't do it. It's happened this one, but it's even happened since then where lawyers have been caught on this. This is the reality. These models are always dreaming. They're going to make up stuff. This is a risk like that we have with these models. There's lots of other risks of these models as well. I think bias of favoring particular groups, you see that in kind of the opposite kind of version of that, where Google is going crazy right now with their text to image, where people are kind of taking advantage of the bias mitigation tools that Google has put into its images and creating all types of things. Very easy in these models to create untrue outputs, hallucinations. When we came from traditional tabular learning, traditional very risky models, we had interpretability tools. We could pick algorithms where we understood what was going on with the models. We don't have the same kind of things for these models. Folks are working on it, but it's not really there. Legal concerns over the data that's going into these models. Do they have permission over that? Once the data comes out of these models, like, is it copywritten data? There was an article today about the plagiarism that's coming out of these models, right? There's concerns like that. There's a whole new realm of security attacks with these models, where prompt injection attacks, red teaming, a whole set of vocabulary, because these models create new information. Yes, they're similar to our old-fashioned models, but they also have some new risks as well. I never really kind of finished with the slide, but you see kind of the impact of jobs already, where I think there was a story on like AI providing ethical advice actually did it better than a human. You see them right already kind of helping out with story design and acting, not necessarily taking over. I think I saw another article on using AI to negotiate an NDA, did a better job going back and forth like that. So we'll see more of that kind of stuff as we try to figure out how they're going to fit into all of this. All right. So that was all the material I wanted to go through. I got lots of questions. I'm ready to kind of jump into that as well through that. So this is your last opportunity to ask your questions now if you have them as we go through this. So let's see. So there was a question here saying, hey, I saw this stuff, in 2023. It wasn't that appealing. Like, what is it now? That's it. And what's happened is that curve that I showed you about the compute and the knowledge of these models. I mean, look, if I could redo my career now, I would have focused on the NLP and caught this trend of large language models earlier like that. I think 3 or 4 years ago, they seemed like toys, right? They would do these things. They would help complete sentences. Maybe they could do a little bit of like topic analysis, but it wasn't easy for most of us to see what was going to be able to come of these models, that they were truly going to be able to keep scaling and getting better and better. And I think that's what's happened is we've had some remarkable trends due to the ability of these models to just handle much better data. And and a lot of good researchers spending time trying to figure out how best to get these models to not only acquire all that knowledge, but how to explain that knowledge in a way that humans like. So that instruction tuning. So instead of just completing stories, they know how to give us a bullet point summary of a story that we want, or they're made to be helpful and give us those A answers. And I think that's what's all made those models kind of much better, much more helpful like that. I don't know anything about the chat with RTX. This is an interesting thing. So a lot of the models that we think about when we think about large language models are things like OpenAI, which run on servers far away. There's a large group of folks that are focused on, hey, I like these large language models, but I want to run it on my own compute environment. I want it in my own my own GPU device. I don't want to have to talk to OpenAI. I want to do this all themselves, right? There's many reasons for this. Some of them just, they don't want to share what they're doing with everybody else for reasons. Others are like, hey, I just want to be able to run this on my own compute. I want to see if I can run this on my own GPU. So there's a local llama is a well-known subreddit that has a lot of the folks that kind of do this, but we've seen a huge emphasis over the last year, and it's really come from the bottom up, where people have wanted to be able to figure out how can we run these models on smaller hardware. And so we've seen efforts around the optimization, what we talked about, where there's methods like quantization, for example, using smaller large language models, kind of distillation of these models to do that, as well as people like, hey, how can I take advantage of current hardware better? So folks have, for example, figured out how to take advantage of Apple laptops, have both CPU and GPU. How can I take advantage of both of those to run a large language model on, my Apple laptop? NVIDIA for a while has focused people, like they want people to use their big expensive GPUs in the cloud, but they've noticed the trend too, where lots of gamers have a brand of cards known as, or a model of cards known as kind of RTX, which, right, if you have a kid and she likes the game, they're probably kind of using that type of model in their computer. And they've added a new package where you can use a large language model with that. So they've recognized the fact that people might want to use this on smaller, cheaper GPU. And so that's another whole current that we're going to continue to see as well. I should really put that as a trend, is some of that stuff. All right. Okay. I'm not sure about the chat, if I'm going to be able to get through all of that stuff. You're going to have to let me know if there are any questions in the chat, or is this like good stuff between the folks?
I haven't seen anything in particular in the chat that you haven't already addressed, or that they haven't put over into the actual Q&A.
Excellent.
Yeah.
All right. Well, we'll see. We'll give people a second or two to see if there's any more kind of questions or any other topics to talk about like that. So,
Well, this was really eye-opening, very very interesting. One I guess one just sort of observation that I've had. Actually, I've really resisted using any of these
Mhm.
things. But I was recently forced to use ChatGPT, so that was a bit of a experience. But anyway, I- I'm I'm sort of wondering if, how after so many years the word Google has become a verb, I guess, and then almost has been is the same as saying I'm searching for something. So in other words, it's another way to say you're doing an online search. Do you get the sense that ChatGPT, that word, I guess, is coming to refer to like all generative AI and large language models, and so that it's become, instead of a particular model, uh, it's coming to represent all of them?
So I'm particularly bad, although part of the reason is I didn't want OpenAI to own the GPT phrase as well. And so I use ChatGPT as a generic word for all this stuff, where the thing is,
As
good.
I say, you're not alone in that. I think I do that. A lot of people do that.
But I think the other question that I think that touches upon is like exactly how people are using it and like how is it fitting in. I mean, for me as kind of a data scientist that codes, like I love using ChatGPT for like answering technical questions or having it debug my code. I literally like cut and paste, like, hey, it's not working, and it like gives me the fix. Or, if you're using something like ggplot, like it can tell you, like, hey, if you're like, hey, I want to, add my plot or I want to change this, it'll literally like tell you exactly the code that you need for that. And so I find that, very invaluable. I think one thing that's going to reduce like the ChatGPT to becoming too generic is there's so many of these LLMs nowadays. Like every time you turn around, right, there's another like search bar that you can type in your thing, right? Whether you're using Snapchat, right, GitHub's or Microsoft has all their Copilot stuff, and right, it's so many customer service chatbots like that. So um, in some ways, like it's come so fast that it's like everywhere like that as well. They'd be interesting if people in the chat like put down like where they've used these models most useful as well. But for me, part of what I do is I help write content, and I've started like using these things all the time. I cut and paste my content in and have it evaluated or give me criticisms like that along the way, like that.
Yeah, I guess I kind of resist those things. Maybe I'm afraid of being replaced. I don't know, but I thought it was interesting about that LLM seem to like themselves.
Absolutely, yes. No, they like themselves. And they also like to please us as well. So that can be the thing you have to watch out for is they like to please us and will love to compliment us because they like that part like that. So
So I
I
found
know
that.
I'm anthropomorphizing the LLMs and I shouldn't do that, but we should recognize also like how they act. They try to pull on the human tendencies as well.
Yeah. Yeah. Well, just to circle back on the slides, if you don't mind sending the slides to me, and I'll check with Donna. I think she did this for us last time, gave me the list of registrants. And I can then email the slides to everybody, and then also let them know where the link is once we get the YouTube video uploaded.
Excellent.
So yeah, any last minute questions?
Oh wait, there's one or two more maybe. Government funded work and then
Oh yeah, that's interesting
so
about the government because I think because of data confidentiality, maybe other security reasons, um it's important that we do have, if we're going to use a large language model, that we can't go out to some third party server somewhere, and we'd have to have something in-house, I would think. So I think your point about having local models is key.
yeah, I mean, I think that the government is very vested in like the open source models, especially because right, those are often kind of meet the different requirements that government has, and you know, anything luckily there so far has been a pretty robust model in that, but steps that the government can do to encourage that, I think would be useful for the government all across its different agencies, departments like that is right. Then they can have models that they can bring in, with their security practices like that.
Well said. Thank
So the
you.
question also was like the future of AI for government funded work. I know I can read that in many different ways, um, as well.
Okay, and I guess I'll just close with one thing. I think you made the point when you were talking about Finbert and
Mhm.
some of those specialized models. I feel like that's an example where when you have, and I think you made this point, when you have smaller models, um, and you should kind of use those. In other words, you don't want to hammer a nail with a sledgehammer.
Exactly. Exactly. Yep.
So, and it sort of reminds me of the beginning of artificial neural nets, where if you were building a classifier, people would say, well, are you going to throw a neural net at it? And so, well, no, try something simpler first before you do something extreme. So
Yeah,
anyways,
we
I
have
thought that was some good examples, good data points.
excellent. Yeah.
how I like Stas's fed bird. That's I love it. All right. Well, thank you so much, Rajiv. Donna, did you have anything further to say before we close it down?
No, I think we're good. Thank you.
Great. Yeah. Thank you everybody for attending, and thank you, Rajiv. I wish we were in person, but here, I don't know if you could hear my applause there, but
Thanks.
all right,
No,
great. Great conversation and presentation. We were really happy to have you with us today. So thank you
excellent.
and best of luck at Snowflake.
Thank you so much. Thanks,
All
everybody.
right, take care. Thanks.
All right. Bye-bye.
Bye.